Hello, myself Tahira Mazumdar. I am assistant professor in IT department from AKGEC Engineering College. Today I'll be talking about digital signatures. It is a topic which comes under cryptography and network security under AK2 syllabus. And these are the topics which I'll be talking about. I'll be talking about the definition of digital signature, what exactly digital signature is. I'll compare a conventional signature with digital signature, how exactly a digital signature process takes place, then what are the security services that digital signature provides, and finally I'll list some schemes of digital signature that are being used, and I'll be talking about RSA digital signature in detail. Okay, to start with, first let us discuss what exactly digital signature is. Now, digital signature is a mathematical scheme. What is the role of this digital signature? What does it do? It is used to provide the authenticity of messages which are in digital form. The concept of digital signature is same as the concept of a manual signature that we provide in paper. When we sign a paper or a document, we authenticate that yes, it is me signing that document and no other person who is taking my role. Similarly, here also, when you're sending a message, we are ensuring that the message is not being tampered upon. If you want to do that, we'll use digital signature concept. Digital signature, what does it provide? First point, it provides authentication, meaning that the data is coming from the right source. Someone else is not pretending as the sender and sending the data. The next is it also provides non-repudiation. That means once the sender sends the data, later on the sender cannot deny that the data is not being sent by him. And finally, the message is not being tampered as it is being transmitted, that is integrity. Integrity is intact, that means the message is sent as it is not being tampered. I'll be talking about this figure more in the next slide. So throughout this class, we will be talking about Alice. We'll be talking about Alice as the sender, and Bob will be referring to Bob as the receiver. Now, before I proceed further, I just want to make a brief comparison between digital signatures and the conventional signature that we normally do on papers. Now, to start with, the first one is that when we are talking about conventional signature, what you do, you include it in the document. For example, we are writing a letter to some person, we are writing a manual letter, and finally we give a signature. So that means digital signature is included in the document. That is the first point. Now, but when you're talking about digital, I'm talking about manual signature. I'm talking about manual signature, it is included in the document. Now, when you're talking about digital signature, it is not, we have to send signature as a separate entity. So that means in case of digital signature, we have to send the document or the message which will say as well as a signature. So this is one entity and the signature is another entity. Unlike in manual where we include the sign in the document itself. Then the next difference is when the receiver gets a copy with a signature, what does she do? I'm talking about the conventional one or the manual one. What does the receiver do? She compares the signature that is on the document with the signature that is on the file to ensure that it is the right signatory person who has signed the document. That is which happens in conventional one. But in the case of digital signature, the receiver, if you remember, as I told, what is sent? The message as well as the signature. These two are sent. So in that case, what the receiver do when it comes to digital signature, the receiver will apply a verification technique to this combination of message. We are sending message as well as signature. This is sent by the sender. This is sent by the sender to the receiver. This is when you're talking about digital signature. Now, in that case, the receiver will apply a verification technique to this message and signature that is being sent. And based on the outcome of the verification technique, the receiver will decide whether to accept that message as an authentic message or not. Now, let me talk about one more difference between a conventional signature and a digital signature. One point is there is normally a one-to-many relationship between a signature and a document. For example, we have document 1, we have document 2. So let us say we are having three documents and we want to give a signature. Conventional signature means signature being signed manually. So you're giving the same signature. We're giving the same signature in all the documents. So when it comes to conventional signatures, the relationship is one to many, one signature to many documents. But when you're talking about digital signature, what is the difference? In case of digital signature, there is a one-to-one relationship. That means if you have document 1, the corresponding digital signature for document 1 will be, let us say, S1. For example, if your document 2, the corresponding signatures will be S2. So different documents will have different signatures. So it is 1-to-1 between signature and message, that is for the digital signature, and 1-to-many for manual signature, which we already are using traditionally. This is just a brief comparison between conventional signatures and digital signatures. Now, now let us next talk about the process that, or rather we'll say the steps that goes into the digital signature process, how exactly things work out when you're talking about digital signature. Now, this is some brief summarization of 4 steps that we follow when you're talking about digital signature. To start with, we have Alice being designated as the sender. We have Bob, who is the receiver. Fine. Now, Alice wants to send a document. Let us consider this document as a message M, for example. So what will Alice do? Every digital signature will have 2 important components. One is a signing algorithm that is at the sender's end. The other one is a verifying algorithm that is at the receiver's end. What will Alice do? Alice will use a signing algorithm to sign the message. So it will use a signing algorithm, and the output of the signing algorithm will be a signature. I'll be talking more about it later on. So what will ultimately, what will Alice send? Alice will send message and signature to Bob, who is the receiver. So the message and the signature are sent to the receiver. Now what the receiver does, the receiver gets this combination of message and signature. The receiver, what it does, it applies a verification algorithm to this combination, and the outcome of the verification algorithm will decide whether the message is to be accepted or not. If the verification algorithm verifies, yes, it is a correct signature, in that case, if the verification algorithm is correct, in that case the message will be accepted, considered an authentic message, or else it will be rejected. These are the brief steps that goes into the process of a digital signature. Now, as I told you, so normally, as I said, we have the signing algorithm and the verifying algorithm. Now, when you're talking about digital signatures, for this signing and verifying algorithm, we need keys to perform signing and verification. We need keys. Now, when you're talking about keys, keys for what purpose? The keys, in the case of digital signature, we go for asymmetric key encryption, or rather we can say public key system. What does it mean? If we have already studied this in some classes back, where public key encryption basically refers to an encryption technique where every sender and the receiver, if this is your sender and this is the receiver, both the sender and the receiver, or rather we can say the communicating parties, will be having 2 sets of keys, the private and the public key. Every communicating component, the private and the public key. So, so when you're talking about public key system, every communicating entity in the network will be having a pair of keys which are named as the private key and the public key. So the first point to note is that when you're talking about keys for digital signature, we'll be going for asymmetric key, or rather we can say public key system. Here, now when you're talking about asymmetric key, so we have Alice as the sender, we have Bob as the receiver. Now, so Alice is, since we are talking about public key system, Alice will have its own set of key. Let us put it as private key of Alice and public key of Alice. Similarly, Bob will also have his own set of key, the private key of Bob and the public key of Bob. Now here, the point to be noted is that when we are talking about public key system, we already have learned about confidentiality. When we consider the task of achieving confidentiality, in that case, what we do is that if you're talking about confidentiality, I just want to compare this with that. For example, we are talking about Alice and we are talking about Bob. Now we have a message M. Now, if we are talking about confidentiality, how do you go about it? In that case, we use the public key of Bob, that is for confidentiality, and then the message, we use the public key of Bob and we get a value. Now to get to at Bob's end, to decrypt that confidential, when you're talking about confidentiality, I'm talking about encryption and decryption. So at Bob's end, Bob uses its own private key to decrypt this particular data which has come from Alice end. That happens when you're talking about crypto system, or rather when you're talking about encryption decryption. Here we don't want we are not talking about confidentiality, we are talking about authentication. So what we do is that in the case of signing of algorithm, what we the key that is used, we use the private key of Alice for signing. So because Alice has, now if you remember, when you're using a pair, for example, the private key of Alice for signing, then in the verification we'll be using the public key of the same entity. If it is Alice private key, then we'll use the public key of Alice only. We cannot use Alice private key and Bob's public key. We should use the keys from the same component. Now here, for the purpose of authentication, we use the private key of Alice. Why? Because everybody cannot authenticate as Alice. Only Alice has to authenticate as Alice. So, and private key of Alice is known only to Alice. So we are ensuring authentication here by using the private key. No one else can do the signing using the private key of Alice. Now, when you're talking about receiving, so this using of the private key of Alice ensures authentication. Why authentication? Because no one else knows the private key of Alice, only Alice knows. So it is ensured that only Alice can sign using the private key of Alice. Now at the receivers, and how to verify, if you're using the private key of Alice, we have to use the corresponding pair, and the corresponding pair is public key of Alice. And if you remember, the private keys are private to the communicating parties, and the public keys are publicly available to everybody. So to verify, Bob can get the public key of Alice and uses that. It is because how can Bob get it? Because it's a public key which can easily be accessible. Now, if you want to differentiate between digital signature and crypto system, because the case of using public keys pair and public and private key pair are used in crypto system also. Now, the main difference is that when you're talking about crypto system, that means when you're talking about encryption or decryption of data. So in that case, we use the private and public key of the receiver. That is the point to be noted. But in case of digital signatures, we are using the private and public key of the sender. There lies the basic difference between the crypto system and the digital signature. Now, I'll be taking an example, RSA, where RSA is an algorithm that is used both as a crypto system and as a digital signature. I'll be explaining how exactly RSA works on digital signature. Now, before talking further, let me now talk about doing a signature on the digest. For example, we want to perform a digital signature on message digest. How to go about it? First of all, what is message digest? What is digest? Basically, digest, for example, we have a message M. To this message M, if we are applying a hash function, then we get a value, let us say M dash. Now, hash function has got the characteristics that it can have an input of diverse size, various size, but the output is of fixed size. Whatever may be the size of the input, the output is of fixed size. We have various kinds of hash functions. Now, when you are applying a hash function, the output that we get from the hash function, this is called as the digest or the message digest. Now, the point what I'm trying to underline is that we can use the digest for signing. What does it mean? It means we have Alice. Alice is the sender, Bob is the receiver. Alice wants to send the message M. So what Alice does is that Alice performs a hash on the message, applies a hash function to the message. Hash function can be SAJ. We have so many different kinds of hash functions, and the output which is given from the hash function is of fixed size. To this output, the signing algorithm is performed. The signing algorithm is performed, and if you remember, as I said, because of authentication, in case of digital signature, we want authentication, and authentication, what to do? We are using the private key of Alice because only Alice knows the private key of Alice, nobody else. So if you're using the private key of Alice, we are ensuring authentication, ताकि someone else cannot pretend as Alice and do the signing. So now what has happened? The signature is generated and the message is generated. What is it? How is it different from the previous algorithm? In the previous algorithm, the signature for generating the signature, the signing purpose was done on the message. Here the signing purpose is done on the hash. So we have what is finally what we have? We have the message M and the sign or the signature S. So what is sent over the network? Message and the signature, both of these are sent over the network, and Bob takes the signature, verifies it again, because for signing the private key of Alice is used, for verifying the corresponding pair is used. So if it is Alice private key, for verifying Alice public key will be used, and for after verifying if the message is authentic, then what happens? The conclusion is that the message is the correct one. We need to accept the message. So in that case, we have the message that can be accepted. Now during the verifying process, because the signing was performed on the hash of the message, or rather on the message digest, the verifying also should be performed on the hash of the message. So we are performing again the hash function on the message at the receiver's end, and then the verification is done. So one requirement is that both the sender and the receiver, they should know what the corresponding hash function is. And normally, why do we go for this digest? Because the messages that are being transmitted over the network, they are normally very long, and we have to use asymmetric encryption. So that is the reason why you go for signing a digest of the message, because in that case, it will be of shorter length. Now, these are some points about the requirements that a digital signature needs to have. The signature obviously will depend on the message that is signed. That is one first requirement. We must use information that is unique to the sender. The signature must be we should use algorithms in such a way so that the signatures can be relatively easy to produce, and it also should be easy to recognize and verify the signature. Another point is that we should generate the signature in such a way that a third party or an attacker cannot forge that signature. So it should be computationally infeasible to forge the signature. So based on keeping this in mind, so we have to come up with our own algorithms for digital signatures. And another point is that it should be practically possible to save a copy of the digital signature in our storage medium, digital storage medium. Now, next point is, what are the services that are provided by the digital signature? Now, a digital signature can provide the following services. If you see, the first three: authentication, integrity, and non-repudiation. These three services are provided by the concept of digital signature, but the last one is not being provided. So in that case, what we do, we have to, if you want confidentiality as well, in that case, we have to do some bit of more extra work. But by default, if we are working on digital signatures, automatically the message that will be transmitting over the network from the sender to the receiver, the message will be authentic. The message will have the property of integrity and non-repudiation by default. And this is an extra feature which is not coming by default. If required, we will be adding that feature. Now, just let me talk about this services that a digital signature provides. To start with, the first one is message authentication. Now, message authentication by default, digital signature, we devise an algorithm in such a way that by default digital signatures can provide message authentication. It's just like a conventional digital signature, because in a conventional digital signature, when you write something on a document and you give a sign, it is taken care of that the person who is signing is the correct signatory authority, and we can also verify that. Similarly, here also, in case of digital signature, authentication is the first requirement that is fulfilled by the concept of digital signature. How so? Because if you remember, we have said at the sender's end and at the receiver's end, we are signing. If you say we have the message and what we are doing, the signing part. For the signing, we are using the private key of the sender. And this very concept of using the private key of the sender ensures authentication. Why? Because nobody else has the private key of the sender. Only that particular sender will know its private key. Anyone else won't know the private key. So, and similarly, the receiver, when the receiver gets this combination of the message and the signature, receiver when this combination is received by the receiver, for verifying this, receiver uses the corresponding pair. What is the corresponding pair? In the encryption, for signing, the private key of the sender was here used. So the receiver will use the public key of the sender. It will use the public key of the sender. This public will be known to everybody. So anyone who gets this message will be able to verify the message, because the public is visible to everybody. But signing can only be done by the sender, no one else, because it is the private key of the sender is only one which the sender has. So by this concept, we are ensuring that authentication is being satisfied. The next point is message integrity. Integrity means ensuring that the message is being transmitted over the network without getting tampered or without getting modified. And so how do we ensure that digital signature preserves the integrity? That in that case, we can ensure that the integrity is preserved. Why so? The same logic here again it applies. That is because during signing, what we are using? We are using the private key of whom? Of the sender. So, and during signing, what is the input? The input is the message. Now, this particular task of signing the message by another person is not possible. If another person cannot sign this message, obviously the person cannot do the forgery or do the manipulation. Why another person cannot sign? Because the private key is not known to that person. The private key of the sender is not known to the person. So this part is done, can only be done by the sender and no one else. So if the message is altered by someone else on the path, the signature will not match. Fine. That is the reason, that is the reason why message integrity is being achieved. So the point is, because we are in the previous slide, because we are using the private key of Alice, which is known only to Alice and no one else, it is ensuring authentication. No one else can pretend as Alice. It is ensuring integrity. No one else can do the modification because the private key is known only to Alice. If somebody else modifies message M, the signature will change. So this very concept of using the private key ensures that we are achieving authentication as well as integrity. Now the next topic, that service that digital signature provides, it is non-repudiation. Now what is non-repudiation? Non-repudiation is, for example, Alice sends a message to Bob at time T1, let us say. But at time T2, Alice is now denying, no, I have not sent the message. That is a case of non-repudiation, which is not a desirable situation. And how to ensure that this thing doesn't arise? Digital signature takes care of that also. How does it do? For that person, we are using a third party, which is a trusted center. And what we do, instead of sending the message directly from Alice to Bob, because there is a chance for Alice to deny later on that Alice has sent, or rather Bob to deny that Bob has received. So we are using a third party in between the sender and the receiver, and the communication is from Alice to the third party and from the third party to the receiver, who is the Bob out here. Now what happens? We have the same logic. We have the message M. We have a signing algorithm. Again, during the signing algorithm, we are using the private key of Alice. This ensures authentication. This ensures integrity, because this is known only to Alice and no one else can tamper here. Now, so we are sending the message as well as the signing algorithm, but here we are sending it to a third party. Third party is coming in between the sender and the receiver. So tomorrow or later on, none of the participating components, or rather Alice or Bob, can deny at all this communication. So the third party, what it does is that Alice gets the message, the same thing which was happening, the same thing happens here. So only difference is that you have got a third party here. So Alice uses the private key for signing. Third party, what does it do? To verify, because Alice private key was used, the corresponding pair will be the public key of here Alice, and this will be used for verifying. After verifying, we have the message. If it is a correct message, verification algorithm results in a positive answer, then the message is being taken care of and it will be stored by the trusted center in its own storage media. And after ensuring that it is actually coming from Alice by verifying that, now Alice, third person, what it does, it takes the message and again signs. The difference here is that the signing is done by the private key of the third party. So the signing is not done by Alice but by the third party. So, and then it is sent to Bob. So what does Bob get? Bob get the message as well as the signature, but here the signature is not generated by the private key of Alice but rather the private key of the third party. So in that case, so for verifying, what will Bob use? Because it has to use the pair. For signing, the private key of the third party or the trust center is used. So for verifying, the corresponding public key of the trust center will be used, and then Bob will take care of the message if the verification algorithm is correct. So here, because there is a third party involved, so later on Alice cannot deny not having sent the message, or rather Bob cannot deny not having received the message, because there is a third party who is involved out here, and the third party has also stored a copy of the message that was being sent from the sender to the receiver. So this is a situation that is taken care of. So by using a third party, we can also ensure non-repudiation by using digital signatures. Then the next point is confidentiality, which is also an important requirement when it comes to cryptography and network security. But unfortunately, digital signature by default does not provide confidentiality. So if we need confidentiality in addition to the features like authentication, integrity, and non-repudiation, in that case, what we do is that we need to have an extra, we need to provide digital signature by adding another layer of encryption and decryption. So we have to add an extra layer. What is the extra layer? This much is the normal digital signature concept. You have the message M. We are signing using the private key of Alice. So we have the message M. We have the signature that is generated. Now what happens is that the entire thing before here we have now before being sent, we want to ensure confidentiality. If you remember, for confidentiality, it is a message which will not be able to be read by others in the network. So to do so, what keys to use? We use the sender's public key. So if you're using, the receiver's public key. So if you're using the receiver's public key for encryption, what happens to decrypt this? What is needed? The corresponding pair. So in the decryption, if Bob's public key is used in encryption, so in the decryption, Bob's private key will be used. And since it is Bob, the private key of Bob will be known only to Bob only to Bob. And so would others. This network, by any third party, let us say Bob, Alice, Bob, let us say John or Mary, whoever is there in the network, they cannot decrypt it. Why? If the encryption is done using Bob's public key, the decryption requires Bob's private key, and it is not known to either John or to Mary, so they will not be able to read what is there in the message, thereby ensuring confidentiality. So the point is, digital signature which offers authentication and confidentiality again through public key system, but they are a little bit similar in the sense that both digital signature and the task of confidentiality, both of them work on public key system or asymmetric key, where we have pairs of private public key. The difference is that when we are going for signing, when you want to sign digitally sign a document, we sign using the sender's private key, and the verification is done using the sender's, this is for, let me come to this slide. The signing is done using the sender's private key, and the verification using the sender's public key. That is for authentication in case of digital signature. Now, but when you are talking about confidentiality, it's just different here. Encryption is done using the public key of the receiver, and decryption is done using the private key of the receiver. There lies the difference. For signing, it is private key of the sender for signing. For verifying, public key of the sender. That is for digital signature. For confidentiality, for encryption, you are using the receiver's public key, and for decryption, you are using the receiver's private key. So if we want confidentiality also in addition to digital signature, this is an extra layer that is being added. Fine. By default, digital signature does not provide confidentiality. Now, these are some schemes of digital signature that are being used nowadays. These are some algorithms, some various famous algorithms that are being used since a few decades. Examples are RSA digital signature scheme, AKGEC digital signature scheme, SNOR digital signature scheme, digital signature standards, ECC or elliptic curve digital signature schemes. These are some algorithms, and I'll be talking about RSA today. So when now we are talking about RSA being used in digital signature as for the purpose of digital signature. Here the roles of private and public key will be different, as I explained in the previous classes. The keys that are used, the private and public key that are used are that of the sender, unlike the case of receiver for crypto system. Next, the sender uses her own private key, as I told you, and the receiver uses the sender's public key. Fine. Now, let me just explain the concept of RSA. We have the message M, we have the signature S. Fine. Now, RSA uses, we have a function M in case of RSA algorithm, and the function, we have a function F, sorry. What does the function do? It works on M, E, and N to deliver the signature, and that is for the signing part. And in the verifying part, the function, what does it do? It takes S, D, and N as input, and then the output, whatever may be the output, that will be used for verifying whether the signature is an authentic one or not. E and N, they are the public key of Alice, and D are the private key of Alice. If we already have learned in RSA for crypto system, where in case of RSA, E and N are private public keys and D is a private key of Alice. So let me straight away come to the key generation part. So what we do is that we need this E, N, message M we know which we want to send. So first task is to know what is E, N, and D. Once we know this, then we'll apply the signing algorithm and the verifying algorithm. So the task of knowing E and D. So the first task is to know those E, D, and N. How to go about it? That is the key generation. What we do is that we take two large prime numbers, P and Q. We try to find the product, which is N. Then we find out phi of N, which is given by Euler's torsion function. Phi of N is a non-negative integer, less than N, and co-prime with N, if you remember, given by Euler's torsion function. So phi of N, as per the definition of Euler's torsion function, is P minus 1 into Q minus 1. Why so? Because P and Q are prime numbers. Now, after that, what we do, we select the number E, which lies between 1 and phi of N, and E is chosen in such a way that it is co-prime to phi of N. Now, after E is chosen, then what we do, we calculate the value of D. What is D? D is basically the inverse of E. There are various ways for finding the multiplicative inverses. We have the various algorithms. So using those algorithms, we'll find the value of D. Once these values are being calculated upon, then we'll find out the value of E, and then what we do is that we'll consider E and N, which we already have taken care of. They will be taken as the public key, and the value D will be taken as the private key. Finally, we have this pair, the public key pair and the private key pair. Once the signing is done, next is the once the key generation is done. Once the key generation is done, next we'll go for signing. So in case of signing, what we do M to the power D mod of N. If you remember, what is D? D is the private key of Alice. Then we have message M and the signature that is generated. In the verifying N, what we do is that at the signature that is being received, what we do S to the power E mod of N. What is E? E is the public key. E and N are public key of Alice. Now, after performing this, we get a value M dash. Then we compare M dash with M. If both are similar, we'll say it is verified that they are equal, correct, not tampered, and then we accept the message. Now, how exactly what happens? Let me just take the proof of that. The proof is that we know. So I just explained the process now. How does this thing actually happen? M to the power D is the signature, right? So at the sender's end, S is generated and M is the message which is being sent to the receiver. Receiver takes S and performs S to the power E. Fine. And then if S to the power E is same as M, then it is correct, we are saying. There is no alteration. Then let us prove how exactly it happens. S to the power E is congruent to M of mod N. How so? Because what is S? What is S? S is M to the power D. So if you replace this, so instead of S, if you write M to the power D, it is M to the power D of E. M to the power, and if you remember, D and E are multiplicative inverse of each other. So if D and E are inverse of each other, the product will obviously be 1. So M to the power D into E is equal to M to the power 1. So it is M congruent. It is congruent to M mod N. So obviously M dash will be equal to M by using this proof, which is exactly same as we have used for RSA in crypto system. So via this, we can verify that the signature that is being generated is verified using the equation for verifying algorithm. Now, this same thing we can also be possible if in this case we are just working on message. We can also choose to work on message digest. The only difference is that unlike this case where we are straightaway taking the message and performing the signing algorithm, here we are not taking the message, we are applying a hash to the message. The digest that we are getting, to that digest we are applying the signing algorithm. Similarly, here also at the receiving, the verifying algorithm, after the verification value D dash, since signature is generated on D, so once the output of the signature, when you are verifying, the output of signature as D dash will be compared to D. If both of these matches, then only we will say the message is not tampered and we will accept the message. So that much for now for RSA. These are the reference books which is also specified in the textbook of the syllabus. Stylings, Cryptography, Network Security Principles and Practices, and the other one is from Ferozan, that is Cryptography and Network Security. That much for now. Thank you.